Look at your surrounding. You can see a doctor can use syringe to inject his patient. You can see a girl blowing a balloon and that balloon become bigger. You can see your mom bakes a bread and that bread rising in the oven. All that happens because of the guest behavior. Most of things in our daily life involve the effect on the guest behavior. The guest behavior can be explained using the guest laws. In this session, we will learn about Boyle's law, Charles' law, and Avogadro'S law, which we can use basic assumption on kinetic molecular theory of gases. Let's start with Boyle's law. Boyle's law states that at constant temperature, the volume occupied by a fixed amount of gas is inversely proportional to the pressure of a gas. This is how to write the relationship between these two variables, which is volume and pressure. Always remember to put the condition of Boyle's law, which is temperature and amount of moles are fixed. Look at the graph of volume versus pressure. We can see clearly that the volume and pressure relate as inversely proportional to each other. When we convert this relationship into equation, we can have the equation of V equal to K over P, where K is constant. After we rearrange the equation, we will have the equation PV equal to K. Let's learn more how to apply Boyle's law. Look at this diagram. At first, this container has a volume about 4.5 liter with pressure of 1 atm. After I compress this container with higher pressure, we can see that the volume is decreasing to about 3.5 liter. If I write the difference in these two conditions, I can write it as V1 higher, P1 lower, and this condition as V2 lower, P2 higher. This clearly applied the Boyle's law, which states that volume is inversely proportional to pressure. And of course, it have to be at fixed amount of moles and temperature. So, the product of P1 V1 will equal to K, and the product of P2 V2 will also equal to the same K value. As both have the same value of K, so we can write it as P1 V1 equal to P2 V2. Next is about Charles' law. Charles' law states that at constant pressure, the volume occupied by a fixed amount of gas is directly proportional to its absolute temperature. We can write it as V directly proportional to temperature, where pressure and amount of moles are fixed. If we look at the graph of volume versus temperature, we can have a straight line with positive slopes, indicates that volume and temperature is directly proportional to each other. If we convert this relationship into the equation, we will have V equal to KT, where K is a constant value. After we rearrange this equation, we will have V over T equal to K. If you look at the both diagram, we can see clearly second diagram ni tengok api dia lebih besar berbanding dengan first diagram. So, it indicates that this diagram will have higher temperature while this diagram has lower temperature. Now fokus kepada volume. Kita dapat lihat bila T tinggi, temperature higher, api lebih besar, the volume will getting larger. While untuk diagram yang ini, temperature is lower than the first one, so the volume kita tengok is lower compared to the first one. Let's say I label this as V1, T1, and this one as V2 and T2. So, kedua-dua ini menjelaskan volume is directly proportional to temperature at fixed amount of mole and pressure. Jadi bila kita write it as product of K, kita akan dapat V1 over T1 equal to K, while V2 over T2 also equal to the same K. Jadi after we combine these two conditions, we will have V1 over T1 equal to V2 over T2. Next is about the Avogadro'S law. Avogadro'S law states that at constant pressure and temperature, the volume of a gas is directly proportional to the number of moles of the gas present. We can write it as V directly proportional to number of moles at fixed pressure and temperature. If we look at the graph of volume versus amount of mole, we can have a straight line with positive slopes. Indicates that volume and amount of moles are directly proportional to each other. When we convert this relationship into the equation, we will have V equal to Kn, where K equal to constant value. And after we rearrange the equation, we will have V over N equal to K. Let's apply Avogadro's law to relate between the volume and amount of mole. Look at this diagram. Kalau kita tengok dua-dua diagram ini, the first diagram mempunyai mole yang kurang berbanding dengan second diagram. Jadi saya akan label dia sebagai N1 lower while N2 higher. So, macam mana nak kaitkan dengan volume? Cuba kita tengok dia punya space here. Clearly we can see that the volume with N1 is lower compared to the volume of N2. So, saya akan label ini sebagai V1 lower, V2 higher. So, ini sebenarnya adalah applying the Avogadro's law, which state that V directly proportional to N at constant temperature and pressure. So, kita boleh apply the product of V1 over N1 equal to K, and V2 over N2 also equal to the same K. Next, we combine both equation, we will have V1 over N1 equal to V2 over N2. Now, let's learn about the combined gas law. Just now, we already discussed about the Boyle's law, Charles' law, and Avogadro's law. After we combine all these three relationships and variables, we will have this kind of relationship, which is V directly proportional to NT over P. After we convert into the equation, we will have V equal to K NT over P, where K is a constant value. And by assuming it is at constant amount of mole, we will have K equal to PV over T. By looking at this diagram, the first container is having temperature of 200 Kelvin and volume 0.5 liter with pressure of 1 atm. After we heat the container, heating means we increase the temperature into 400 Kelvin. So look at what happened to the volume here. It is getting larger with the pressure of 1 atm. So we can see this relate between temperature, volume and pressure. By using the combined gas law, we will have the product of P1 V1 over T1 equal to K, while P2 V2 over T2 also equal to the same K values. Next, we will have this relationship, which is P1 V1 over T1 equal to P2 V2 over T2. Okay, that's all for now. Thank you for watching. Happy studying. See you in the next session.